All right, let's talk solutions and dilutions. So, a solution is made when you dissolve a solute in a solvent, right? So what we're looking at to calculate the concentration of a solution, we have to take the number of moles in there, which is N, divided by the volume of solvent, okay, or the total volume. And the standard unit for volume here has to be in cubic decimeters, as it states there, which is the same as liters. Okay, so the concentration will be moles of solute over total volume of solution. And then if you're doing a dilution, meaning like if you're taking an existing solution with a certain concentration in moles per cubic decimeter and a certain volume in cubic decimeters, if you multiply C1 times V1, it's equal to C2 times V2. And what you hopefully realize here is that that means the number of moles in solution A is equal to the number of moles in solution B. Okay, because we haven't added or taken away any solute, but it's just been diluted. Water's been added. Okay, so if you want to calculate dilutions, you use C1 V1 equals C2 V2. Let's have a gander. Okay, so let's start with this one. A juice drink is found to have 16 grams of glucose dissolved in 250 cubic centimeters of water. Determine the concentration of glucose in the solution. All right, well, determine the concentration. Let's start there. So we know that concentration is N over V, according to the concentration formula. So we just had to figure out how do we get N and V. Well, what we have is we have this value, 16 grams. You should recognize that that is a mass. Okay, so we have a mass. And we've got this here, 250 cubic centimeters. That is a volume. So that can pretty much go in as our volume. The only issue is that we need to convert that volume to the standard unit of volume, which is a cubic decimeter. So 1 cubic decimeter is 10 to the 3 cubic centimeters. In other words, this becomes 0.250 cubic decimeters. So that's what we're going to want to use for our volume. So that can go in for V. So have to figure out N. So in order to get the number of moles for mass, what do you have to do? Well, you will have to use the molar mass, or the relative molecular mass, of glucose from the periodic table in order to solve for moles, and we'll have to use the formula. The number of moles is equal to the mass divided by the molecular mass. Okay, so let's get the molecular mass of glucose, C6H12O6. That's going to be, okay, carbon is 12.01 times 6 of them. Hydrogen is 1.01 times 12 of them. And oxygen is 16.00 times 6 of them. You add that all up, and you get 180.18 grams per mole. Okay? Alright, so that's going to go in there, and the mass is going to go in there, which we had as 16 grams. So let's pump it all in. 16 divided by 180.18 grams per mole. And that is equal to 0.0888, what a lucky number, moles. Okay, so that's our value of N. Alright. We are off to the races. I'm just gonna switch colors here so you can see what I'm doing. So there's our number of moles, and there's our volume, and we're gonna sub those guys in there. Ta-da! All right, so 0.0888 moles divided by 0.250 cubic decimeters gives you a concentration of 0.355 moles per cubic decimeter, which is the standard unit of concentration that we're after. So the concentration of glucose in this juice drink is 0.355 moles per cubic decimeter. All right, let's take this one on. What volume of a 5 mole per cubic decimeter copper sulfate solution must be diluted to make 160 cubic centimeters of 0.30 moles per cubic decimeter copper sulfate solution? So we have the term being just thrown around here, diluted. So we know this is a dilution situation, okay? We know we're going to have to use C1V1 equals C2V2. The question is, can we determine all these values? Well, here's the first solution, is the ones labeled with a subscript 1. So that right here is going to be your C1. Okay, so your original solution had a concentration of 5 capital M, 5.0 moles per cubic decimeter. The question is, what volume of it do we need? So we're searching for V1 here. Okay, our final target concentration has been given to us here. It's 0.30 moles per cubic decimeter, and the total volume of it that we want is 160 cubic centimeters. Now again, remember, we want to keep things in our standard unit of volume if at all possible. Even though if you pumped in 160 here, you're going to get a perfectly reasonable answer, but let's just get used to changing it. So it's 0.160 cubic decimeters. Okay, in we go. We're going to rearrange it to solve for V1. So V1 is C2, V2 divided by C1. And in it all goes 0.30, volume 0.160, concentration 5.0. Solve it up. What do you get? You get 0.0096 cubic decimeters. Okay, or that is the same as saying 9.6 cubic centimeters. All right, so that is the volume of the original concentrated solution, this one right here. The original concentrated solution we would need would be 9.6 cubic centimeters of it. Now, importantly, and I added this question in because I think it's conceptually important, Part B, outline how this would be done in the lab. So what does this mean? How would you actually do this? Well, what you would do here, in order to make this happen, I'm just going to sort of slide this whole thing up if I can, a wee bit, is knowing that you need that amount of original, you would take 9.6 cubic centimeters from the 5 molar solution. How would you actually measure that? You know, well, it's around 10 milliliters. You'd probably use a graduated cylinder, so we can add that in. Take 9.6 cubic centimeters from the 5 mole per cubic decimeter solution using a 10 milliliter graduated cylinder. Oh, my writing. Graduated cylinder. And pour that into a large vessel. Let's say a beaker. Big enough to hold the whole thing, a 250 milliliter beaker. Then add, how much water do we have to add to it? Well, we want the total volume, if you look up top, we want the total volume to be 160 cubic centimeters. So how much are we going to have to add to 9.6? 160 minus 9.6, right? So then add, what is that, 150.4 milliliters of water. I should do this right. Distilled water. I'm not just going to add any old random tap water to the sample. Add that much distilled water. With, let's just say, with measuring cylinders, so that you do it accurately. Okay, so basically in the end, how you do this is you're going to take 9.6 cubic centimeters from the concentrated solution, and then you are going to put that into a new vessel, which is a beaker, and then you're going to top that up with distilled water to make the total volume 160 cubic centimeters. I hope this was helpful in helping you understand solutions, concentration, and dilutions.